Hello, my name is Yucheng Ma. In this video, I'm going to talk about the automatic summarization of interview questions, a project I did for my pattern recognition class. Why interview question summarization? We know that Glassdoor have a lot of reviews of interview processes of a lot of companies in which you can find interview questions that you may actually meet in your own interviews. However, there are a lot of such reviews. For example, there were more than 2,000 reviews just for Google Software Engineer, and it would take a lot of time to go through all these reviews and summarize the questions yourself. So an automatic tool will be handy. There is no existing approach to solve this problem. However, this interview question summarization task is related to document summarization and sentence classification. Document summarization have many approaches. For example, the most common one is based on the word probability, which counts the number of occurrences of the words to determine the importance of the word and the importance of the sentences containing these words. And an extension of the word probability is the CF times IDF algorithm, which will be discussed in my project, and I will elaborate this concept later. And there are other approaches such as graph-based methods, among which the page ranking is one of them, and machine learning approaches. Sentence classification is another well-studied natural language processing task. Sentence classification classifies the sentences into different categories, such as, in this case, interview questions or non-interview questions. There are a lot of classifiers that can be used for sentence classification. For example, naive Bayes classifier or support vector machines, though one of the most popular classifiers, or you can use recursive neural networks. In this project, the SVM will be discussed. So let's talk about the project outline. First, I will talk about how I build the dataset, and then I will elaborate the TF times IDF weighting algorithm, and then I will talk about sentence classification. The project also gives a simple user interface, and then the evaluation of these algorithms will be discussed. First, building the dataset. Since this is a very particular natural language processing task, there is no existing dataset, so I have to build one from scratch. When building the dataset, I find that interview questions are highly dependent on the job position, meaning for different job positions, the interview questions have very different characteristics. So I confine this project to only one job position, that is the software engineer. And first of all, I have to retrieve all the HTML pages containing the reviews. This can be done with Google search and web crawling, which just follows the next page links in the Glassdoor.com to retrieve all the relevant HTML pages corresponding to a specific position. And with all these HTML pages, I have to perform HTML parsing, which basically just extract the reviews from the HTML, because there are other stuff such as ads and some other materials in the web page. And then I have to remove the HTML tags and remove redundant texts. For example, like the job description section titles. Then I will obtain a list of strings containing the contents of the web page, and then I'll use the NLTK, a Python toolkit, to segment these strings into sentences, and then I will hand classify all these sentences into two categories. interview questions or non-interview question. I have classified a total number of 1,235 sentences, more than 250 are labeled as interview questions, and these data are then used as training set and testing set for the sentence classification, and the testing set is also used to test the TF times IDF algorithm. Now let's talk about the TF times IDF weighting algorithm. The term frequency means the number of times a term or a word appear in the document. It is reasonable to think that the more often a word occurs, the more important the word is in this document. However, this rule does not apply to some common words such as pronouns like I, we, you, or prepositions such as with, in. So we should use another criteria to identify these common words. That is why we used an inverse document frequency, which is inverse to the number of documents a certain word occurring. For example, if I have a background corpus of 10 documents and the word with appear in all of them, then the inverse document frequency of with will be 0. So the term frequency times inverse document frequency, or TF times IDF, will identify the words that appear frequently in this particular document but not common to all documents. With the TF times IDF weighting of all the words, we can calculate the ranks of all the sentences. The sentence ranking is just the average normalized word weighting of all the words in the sentence. However, in this interview question with extraction task, we have to predefine a threshold and the sentence which has rankings above the threshold will be extracted. We can see that the TF times IDF approach has the advantage that there is no need to pre-classify any training dataset, which means that TF times IDF is easy to implement and easy to be used. However, there are certain drawbacks of this algorithm. First of all, certain words will have high TF times IDF weighting, but should not be included in the interview sentences. For example, the company name here, like Microsoft here, and some words should be included. For example, like the how, which is indicative of an interview question. However, these words may occur in all of the reviews, so the IDF term will set these words to 0, which is what we not want. And another drawback is that the polymorphism of English words, for example, longest and long, should be recognized as one word, and I use the Stammer tool in the NRTK to solve this problem. Next, we will talk about sentence classification. SVM will not be elaborated. You can learn about this topic in any machine learning book, and this machine learning in action is one I particularly recommend because it is a practical guide of all the basic machine learning algorithms. In sentence classification, one of the most important tasks is to select the correct features to best characterize the sentences to be classified. In this project, the feature vector I selected includes TF times IDF, whose importance I just talked about, and sentence positions, because interview questions often appear in the end of a interview review and very unlikely to appear in the beginning of the interview reviews. So a sentence position counting from the start of the review and a sentence position counting from the end of the review will be given in the feature vector. And then I also include an indicative word flag which identifies if the sentence contains the indicative words such as what, when, why, and how, the words that is common to all the interview questions, which will be ruled out in the TF times IDF term. And for the SVM I used, there are two parameters: the constant C in the in the objective function, and the gamma in the kernel function. And I will discuss how these two parameters will be chosen. In this project, I also provide a user interface, which is a simple HTML page containing two forms that you can type in the company and the position you want to search, and when you click submit, the program will return a web page containing all the extracted interview questions. Okay, let's see the evaluation of the two algorithms. For TF times IDF, the background corpus I used include all these pronouns, prepositions, conjunctions, nouns like questions, process that is very common in the interview reviews, and verbs like take and apply. And for the testing set, the TF times IDF terms with the highest weighting are the Byte, Microsoft, Matrix, these terms. It is obvious that like the STL tree Byte terms are highly relevant to the software engineer position. However, the Microsoft is just a company name, which shows the drawback of the TF times IDF. And here I illustrate the values of the threshold, how the value of the threshold impact the accuracy of the extraction. We can see that high threshold value will result in increased accuracy, but the precision will varies, and the recall rate will be dropped. And it is important to find a threshold value that balance these three indices of the performance of the algorithm. However, since the threshold should be predetermined to allow the TF times IDF to run in the first place, this can be considered as another drawback of this algorithm. And we talked about it earlier that SVM has two parameters, that is the constant C and the constant gamma in the kernel function. We can see that the parameter C has little impact on the performance of the SVM. However, the parameter gamma in the kernel function has significant influences on the performance. Larger gamma value will significantly increase the accuracy, recall, and precision. So I used an iterative searching approach to determine the best parameters, which is given here. C equals to 200 and gamma equals to 2000. And with these two parameters, we can see that the precision is about 40% and the recall rate is about 34%. We can compare these values to the TF times IDF. For TF times IDF, when the threshold value gives a accuracy of 70%, the recall rate is only about 20%, and the precision is only about 30%. That is 10% lower than the SVM results. However, we can see that even though the SVM is better than the TF times IDF, it is not as satisfactory as expected. That's because, first of all, we have a limited training set, because the training set have to be hand classified by myself, and another reason is that natural language processing is itself a very difficult task, and SVM may simply be not enough for this complicated task. So the conclusion is that TF times IDF is easy to implement. It does not require training set, but it performs worse than SVM and is not flexible. And in SVM, feature selection is very important, meaning that if you cannot select the correct features that best characterize the inputs, it is likely that the SVM will have very bad performance. And the SVM often requires large training data set, but it is more flexible because you can put a lot of complicated features in the input vector. For example, the semantic analysis of the words can be somehow contained in the feature vector. In summary, the interview question retrieval task is very tricky, and the performance in this project is not satisfactory. But with future works, I believe that these tasks can one day be solved successfully.